Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform partial fraction method, case number 3 when factors are real and quadratic. Example, find inverse Laplace of 1 by s square into 1 upon s square plus 16. Here there are two factors. The first one is real and repeated, and the second one is real and quadratic. And therefore, to find the inverse, we use the technique. Therefore, that 1 upon s square into 1 upon s square plus 16 is equals to a upon first factor, that is s. As it is repeated, next is b upon s square, and for this quadratic, next one is cs plus d divided by s square plus 16. We call this as equation 1. Here it is a proper fraction, as the degree of numerator term is 0 and degree of denominator term is ss to 4, means 4. 0 less than 4, and hence it is proper fraction. And as it is proper fraction, we can perform partial fraction as in equation 1. Then LCM is s square into s square plus 16, dividing by s, we get 1 is equal to a into s, dividing s into this s square plus 16, b into s square get cancelled, remaining is s square plus 16. Therefore, b into that term s square plus 16, cs plus d, dividing by s square plus 16, s square plus 16 get cancelled, remaining is s square. Therefore, multiply by that s square. Then simplifying it, we get as cube plus 16as, then bs square plus 16b, cs cube and ds square. Collecting the terms of s cube, s square and sn constant term. Therefore, there are two terms of s cube. Therefore, remaining is a plus c into s cube. Then terms of s square 1, 2. Therefore, taking s square common from this, we get b plus d into s square. Then collecting the terms of s, only one term of s, that is 16as, and collecting the terms of constant term, that is 16b. Comparing these two sides, the coefficient of s cube is here a plus c, and no term of s cube on the left hand side, therefore it is equals to 0. It implies a is equal to minus c. Then coefficient of s square is b plus d, no term of s square, therefore it is equals to 0. Then coefficient of s is 16a, no term of s, therefore it is equals to 0. It implies a is equals to 0, and if a is 0, substitute that value here, we get c is equals to 0. Then constant term 16b is equals to, constant term on left hand side is 1. It implies b is equals to 1 by 16. And if b is equals to 1 by 16, from this we get the value of d as minus b, and therefore it is minus 1 by 16. Therefore, substituting these four values of A, B, C and D in equation 1, we get A is 0, C is 0, B is 1 by 16 and D is minus 1 by 16. We get. Substituting the values, this equation 1 becomes 1 upon s square into s square plus 16 is equals to value of A is 0, first term 0, B is 1 by 16 divided by s square, C is 0 and A is minus 1 by 16 divided by s square plus 16. And then taking inverse on both sides. Therefore, inverse Laplace of 1 upon s square into s square plus 16 is equals to inverse of this term, taking individual inverse, therefore 1 by 16 outside as it is constant term, inverse of 1 by s square and minus 1 by 16 constant term, inverse Laplace of 1 upon s square plus 16. 16 means 4 square. Then applying the standard result. Therefore, it is 1 by 16, 1 by s square, s raised to n, n is here 2, positive integer. It is t raised to n minus 1 means 2 minus 1, that is 1, divided by 1 factorial, and minus 1 by 16, inverse of 1 upon s square plus a square is 1 by a, 1 by 4, sine of at, sine of 4t. And therefore, simplifying it, we get t by 16 minus sine 4t divided by 64 as the required answer, or required inverse Laplace transform. Therefore, total 3 examples I have discussed for this case number 3rd, when factors are real and quadratic, through that 3 separate videos. In my next video, I will discuss another important technique to find the inverse, that is convolution method. If you like my video, please share it as well as subscribe to my channel to receive the notification for all such type of new videos. Press the bell icon. Thank you. Thanks for watching.